Hi everyone, welcome. Thank you so much for bearing with us. We had some technical difficulties, but it's resolved now. Thank you. Welcome to ACH 2024, second day. I hope you're all doing well and a little refueled now that we're after lunch. Thank you so much for joining us. My name is Roaa Marei, and I'm a junior at Harvard studying mechanical engineering and social anthropology. And I'm the chief of staff and content director for ACH, part of the organizing team. This is the 16th annual conference at Harvard, and we've never had a space segment. And because I'm very passionate about this topic, I decided to lead this and moderate this panel with two esteemed speakers, now that I've been leading discussions with them for a couple of months now. And our panel discussion will tackle space exploration, space applications, natural hazards, and climate change, especially in the Arab world. Today, we have the privilege of hearing from experts in these fields, like Dr. Tahani Amer and Dr. Essam Heggy. It is my honor to introduce our distinguished panelists for today's discussion. First, Dr. Tahani Amer is the Acting Associate Director for Flight Programs for the Astrophysics Division and the Science Mission Directorate at NASA headquarters. Her work underscores the urgent need for innovative solutions to mitigate the impacts of climate change. Joining Dr. Tahani is Dr. Essam Heggy, who is a research scientist at the Microwave Systems, Sensors and Imaging Lab at the Viterbi School of Engineering in the University of Southern California. He is an affiliate of the Radar Science and Engineering section at NASA's Jet Propulsion Laboratory and associate professor at the Institute of Earth Physics of Paris at the University of Paris in France. Together, they will bring a wealth of knowledge, experience, and passion to our discussion today. So please join me in welcoming them. To situate our panel within the world and its importance, let me start with some recent events that maybe some of you have heard of. 16,000 people died in Libya from a flood, 3,000 in an earthquake in Morocco, water stress impacting food prices in Egypt, and disruption in energy in the Red Sea. More events like these show the climate and environmental crises in the Middle East is now having global impacts, not just in the Arab world, but everywhere. So this topic is of huge importance, especially now more than ever. Our goal as societies and leaders, organizations, activists, students, and even humans should be to build better and sustainable future for all. One organization that is well known and plays a crucial role in understanding natural hazards and climate change is the National Aeronautics and Space Administration, better known as NASA. It does this specifically through its Earth Science Division.
Our scientific discoveries reveal a complex web, a system of systems. Down every thread we follow, we find new connections we did not expect. We have so much yet to discover, if we go looking for it. The next generation of Earth science begins today. An array of cutting-edge satellites brought together into one observatory to make connections beyond current boundaries. A new way to see our home so that we can rise to the challenges ahead. Together. Join us on our journey of discovery so that we and our home may thrive.
So, this observatory is essentially a set of Earth-focused missions designed to provide key information to guide efforts related to climate change, disaster mitigation, fighting forest fires, and improving real-time agricultural processes. So, as we saw, these important observations that we gain from what NASA is doing help scientists, emergency responders, better understand and predict these events. in improving preparedness and response efforts in our world, and especially the Arab world. Now, Dr. Tahani Amer, please take it away.
Good afternoon, everyone, and thank you for inviting me. Can you hear me?
Yep.
Okay, great. And I'm sorry about the delay, this technical difficulty here. It's an honor to be here with you. I just want to give you a little bit of perspective. Next chart, please. Can I say next? So one day, I was like you are, sitting in the audience right there. So I came from Cairo, Egypt, like a few of you in here, and now I'm in the Potomac River working for NASA. I'm just going to give you a little bit of an inspiring speech first, and then I'll tell you about my work at NASA. And actually, the video that Roaa showed, I worked in all this mission. I haven't seen that video yet, but I worked in the actual mission, so it's exciting to see that. Next chart, please. So who am I? I'm a person, came to the United States when I was 17. I went to school in the United States. I did actually have a black belt, a Six Sigma. It's not the black belt karate things, but Six Sigma. It's a zero tolerance activity. I did a lot of work at NASA, from aeronautic to earth science to planetary science to now astrophysics. It's been a really great challenge. And actually, I was a student of Harvard, but Harvard Business School. NASA sent me there, and worked in business school. So I not only engineering background, is business background and strategic thinking background. And I was very honored and blessed to work in a lot of area. And probably some of them you probably heard of, like James Webb Telescope, the Artemis SLS, Orions, and the last mission that I worked on in earth science is called SWOT, Surface Water Ocean Topography, that launched 2022. And now we're working on new telescopes called the Roman telescopes, and it's really exciting to be part of that. So I'm just letting you know, if you have a dream and you work hard, you will achieve there. I'm not unique. All of you are very, very, smart and capable individual. And one day I expect you to be in my seat. Okay. So that's kind of my general talk. I'm just telling you my trip. Next chart, please. So what is really part of this conference? What is part of being an Arab? How can we contribute? We are just one of many, but if we are together, we can do a lot of things. So when I was in COP27 in Sharm el-Sheikh, I was able to present to the United States, and I did the opening ceremony, and they wanted me to talk about certain things. And I said, the only thing is we can do, all of us together, is to learn something every day, and then respect our heritage. Do not forget who you are. That's one thing. The other thing is to build collaboration, because we don't do anything by ourselves. We live in community, we live in society, we live in nations, so we have to do that. And then, of course, we have to inspire the next generations, right? We have to solve the problem together, build the synergy across the boundary to be able to do that. So I thought this kind of chart is very relevant to what we're talking about in this conference. So if anything you want to take out of this is this chart, not anything else that I do at NASA, okay? So next chart. So what we really do in earth science specifically, so NASA has multiple missions. We have space sector, we have technology development sector, and then we have earth science. Earth science is, we call it the earth science is eye in the sky, that we see Earth from different perspective. We develop technologies so we can understand how our Earth system works. We develop missions, flights. We have 24 satellites that look at the Earth and try to understand the dynamic of the Earth system as an ecosystem. Then we have research and analysis. People like Dr. Essam and his scientists be able to understand what is this mission, what does this data looks like, right? And then we have data, and then we have modeling, so we can predict what can be happening in the future, right? Then actually, Earth Science Action, this is actually my friends. Marei is right there taking data of somewhere, and because what you learn from our satellite, from our mission, from our data, we have to implement in Earth and be able to protect our Earth planet. So next chart, please. So if you look at the Earth, we look at as a system, as a whole, right? We look at from the atmospheric composition, we look at the carbon cycle, we look at the climate variation, we look at the water cycle, the energy cycle. All of it's connected together that give us the effect of what's happening to our climate change and why it's happening. Not one satellite that does this, combination of them, actually 24 of them. And we just launched one PACE missions not too long ago that give us another dimensions of Earth circle. And then all of this data are free and open to anybody in the world can look at it. And then I will let you know there is another website that you can even see the temperature, the carbon precipitation in the atmosphere, where in every second of the Earth. It's called science, nasa.gov, vital signs or something like that, to be able to monitor everything from all our satellite. And you actually can find the locations of your area and be able to get all of this. What does this really do? It gives us, we are there to bring knowledge, informations. NASA does not do policy, does not change anything at the government what to do. We just give the facts. It's up to us to just give the facts. And other people that need to change things, that they take this information, informed decision to be able to make that. Next chart, please. Now, this chart here to give you the aerosol optic changes in our mission. But the reason I put this here is to show you how is we all connected together, right? There's no, when we see Earth from space, we call it the overview perspective. What does that mean? Everything happened in Africa, everything happened in Asia affect us here, right? So we are one system that's affected. So we say, oh, what happened in Dubai does not affect us here. It does affect us, right? In all aspects. Any pollution is happening in India, it affects us here. So it's a one system that does affect us all. And we can see there's changes. Look at the carbon effect, look at the sulfur, look at the dust, look at the salt, and all of this really gonna affect our planet. And we have to work together to be able to understand how to really mitigate this situation that we're in, and how to really adapt and be ready for any extreme weather environment that we can see that we cannot really predict. So this is shows we connected together. And then the next one, it shows that how many satellites, you can push the play button there, and it show you this is all our satellites. In every minute that one of our satellites is looking at part of the Earth and give us some information and tell us how our climate changes and how is the data that every one of our activity that affect the climate. So we need to be respectful of that and be able to protect our home planet. And you can see my favorite one is SWAT. So now NASA has multiple satellite that we're working on. Some of them are in ISS, International Space Stations, and some of them in operation, some of them in development. We have a fleet that really consists of all aspects of Earth that we're looking at. And that's all what I wanted to cover with you. I'm here to answer any question for you, and I would like to give it to my colleague, Dr. Essam, to continue talking about this. We can talk about my equation later on after toward the end. Okay. Thank you for listening. Essam.
Many thanks, Dr. Tahani. This is really an inspiring, and I just want to say, people ask always this question, the image of NASA in the mind of many people, especially in the Middle East, that is just landing on the moon and exploring the planets. And what we see here is that there is an increasing interest in NASA, in most space agency, to understand the Earth, because we realized in the last 20 years that the planet we live in has changed and become, it's much unknown to the planets we are actually exploring. So I would like to introduce myself. So I am a scientist. I work on natural disasters and exploring the planet. So as I work in the last 10 years on natural disasters in the Middle East, this has mean that I have been very busy, because every 2 weeks to a month we have a disaster. And the last one is what happened in Oman and in UAE, which is the storm that happened from the 14th and 16th of April. And that storm that did the floods. And these floods, many misconceptions, they were assimilated to the artificial seeding of the clouds. And the image we see here shows that this is not true at all. The precipitation is originating from the Gulf of Oman So it has nothing to do with the seeding of the clouds at all. Next slide. So I work in two places. So the first one is the NASA Jet Propulsion Lab. It's managed by California Institute of Technology, and it was established in 1934, and it joined NASA in 1959. Next slide. And the second place is the University of Southern California. And for those of you here in the room who do not know, it's very famous by Neil Armstrong. Well, okay, we know that Neil Armstrong was the first man to walk on the moon. But many of you, if not all of you, do not know that Neil Armstrong, when he walked on the moon, he was a graduate student of USC. He was a master student in USC. So he was enrolled in master 6 months before he walked on the moon, and he obtained his master 9 months after he came back from the moon, making Neil Armstrong the most famous graduate student on the planet. I can tell you, advisor, oh, I'm going to the moon and back. It's an excellent internship. So I work in the School of Engineering, in the same School of Engineering. So what I do is that I study water on planets, including the Earth. And why we study water on planets? Because water on planets, we're not going to drink this water or explore this water, but water, it adds the complexity to planets. It makes the mineralogy more complex, it complicates the system of any planet, and that is the building element for life. And so many people say, oh, why don't we stay focused on the Earth? You guys are wasting your money and your time looking to planets. In fact, the focus is the Earth. If you see the planets you see here, every one of them would represent a phase that the Earth has went through. So for instance, for Mars is the future of our planet. Venus is the past of our planet. The icy moons of Jupiter that are completely covered with ice is the Earth during the Ice Age. The asteroids and comets, they changed the way we live on our planet. So this is the main objective, is to study our own planets. Next slide. So, and one of the least question which is known about the planet, what is the impact of climate change in arid areas? And many people, they think that arid areas, this is desert, Sahara, there is no change. And that's what we see from planets. This is not true. Next slide. So I work actually on 3 missions for Mars, which is the Mars Express, the Mars Reconnaissance Orbiter, and the ExoMars mission. And the 3 of them use the radar to look for traces of water and ice on the subsurface of Mars. Next slide. So when I started my PhD and I defended in 2002, and these missions were brand new, and then people will tell us this is not the science. I mean, the science is really what people were doing in the past, not radar. And we ended up in the cover of Science magazine in 2008 with the analysis of the polar layer deposit on Mars, and we showed that the poles of Mars are stratified, which means water stayed long enough on Mars to make the stratas, which is mean that life could have existed on Mars for maybe. Next slide. So I also worked on the Rosetta mission, which is a mission aiming to explore comets. It's the first landing we had on a comet. It's a mission by the European Space Agency, and it's the biggest planetary mission. So this is, you see the solar panels of the Rosetta mission. When it is fully deployed, it's a half of a football field, and the mission took 14 years to reach Comet 67P. Next slide. So we worked on understanding the origin of water on Mars, and we find that water on Mars, we see today these flood feature, we see, like wadis on Mars that are very recent. And we decrypted the origins of these recent flow feature to be made by groundwater and not by rain, as people suggested, and we published that in Nature Geoscience a few years ago. Next slide. And one of the things that one of the beautiful experiences I felt in my life is to be in a rescue operation. When the Rosetta mission, when we landed on Comet 67P, we lost the lander. And we started a 2 years operation to retrieve a lander 720 million kilometers from the Earth, just using a radar signal. And we located the position of the lander, And we published it that in Science. Next slide. And then in the last day of the mission termination, when we have to land the spacecraft, the whole spacecraft, to smash on the surface of Comet 67P, we located the lander, and as you can see it in the red box here, and the lander was flipped. And why it was so important to locate the lander? Because we were able to download the data from the lander and to relate the physical properties measured by the lander to this location. Next slide. So if you go to the Museum of Sciences in Berlin, they have a display where they put the people who participated in this biggest rescue operation of spacecraft, and my picture is one of them, which is here. So, next slide. And so also we work on the Dawn mission, and I think it was not displaying very well, where we identified the ice on asteroids. People can say, why do we care about ice on asteroids? Ice on asteroids is very important because it can make, if an asteroid would hit the moon and have enough of ice on it, it can bring that ice to the moon, making the moon have an atmosphere and maybe to form a condition for life on a dead body. Next. And that paper was published in Nature on the cover page, and it was an editorial choice of Nature. Next. So, and as everybody who work in NASA or dream about working in NASA had this opportunity to train the astronaut to look for water on planets. Now, I just want to make a disclaimer. My PhD has nothing to do with planets. My PhD was the most boring PhD on the planet, is to look for water in the desert. It was a PhD, it's funded by the equivalent of the USAID, so an agency for food development in France. And I was supposed to find water in desert in Egypt and go back. In the end, I ended up finding it on the moon, on asteroids, on planets, and Jupiter icy moons. Train the astronauts to go and find it. Next slide. But, so, and this is the lunar electrical vehicle, which have this radar that we designed it to help the astronaut look for ice on the surface of the moon. Next. And these are the NASA Ames modules that were aimed to host the astronauts to leave and provide them some mobility outside the extravehicular activity. Next. And these are so the real astronauts. So if you like fashions, the astronaut suits is $18 million. It's the most expensive dress on the planet. Next. And these are the astronauts locating the ice, the samples that we trained them to retrieve. And these are real ones. Next. So in the end, I would just want to say it was a pleasure to do all of this stuff. If you search my name in English, you will get maybe stuff on CBS News, CNN News, something about science. If you Google the same name in Arabic, you will find horrifying things. So I don't want to go in there, but let's go next. Next. And so after 20 years for looking on water on planets and everything, I decided to go back to the topic of my PhD, and then we designed this mission, which is called Oasis, which will look for the groundwater in the Sahara and to measure the thickness of the ice sheets, and that will provide a better understanding of sea level rise in the next 30 years. So we can display the video of the mission, and that will be the last thing. It has a sound, so maybe we want to take a sound. Should be right.
We see deserts expanding, and the ice sheets are shrinking. There is no denying that our planet is undergoing rapid change. Since the dawn of the Industrial Revolution, humans have been emitting larger and larger amounts of climate-warming gases. This in turn is causing the planet to warm. The results are ice sheets melting and sea levels rising, which causes shorelines to retreat, threaten our cities, and infringe on valuable reservoirs of water that lie below the desert surface. Increased pumping of groundwater actually accelerates sea level rise. Low-lying areas such as Florida and the Arabian Peninsula are particularly vulnerable, and so we must know more. Once launched, OASIS will study the Earth's shrinking ice and aquifers. The constellation of satellites will bounce radio waves off the Earth's surface. OASIS will use these measurements to observe melting over Greenland and the aquifers under the deserts, and Antarctic ice thickness. OASIS, helping humanity prepare for a rapidly changing planet.
So that's it. So this is after 20 years, I'm back to do what I was supposed to do with my PhD. Thank you, everybody.
Thank you. Is that okay? Thank you, Dr. Essam and Dr. Tahani. So Dr. Tahani also mentioned the importance of collaboration, and everything is a team effort, and you cannot do anything alone. So in the spirit of collaboration and innovation, since they're essential for addressing global challenges, especially in the Arab world, and sometimes it is also important to look at things through the lens of young engineers and scientists, as a mechanical engineer myself. So Dr. Tahani and Dr. Essam, what advice would you give to younger generations or aspiring engineers and scientists?
Can I get my equation?
Of course.
Okay.
Good.
So you cannot get away without an equation if you're a scientist and engineers, right? So I've been giving a lot of talk across the world, right? And everybody said, what's your equation of success? So one day I sat down and thought about it, right? And I said, okay, I'm going to write something that really makes who I am. And you could tweak this equation and change it anyway. But one of those days I'm going to write a book about it. So I call it the Amer equation of success. So it goes like this: I P cube plus R over T. What does it really mean, right? So I, it means you imagine your future. What's going to look like in 3, 5, 10, 15 years in all aspects. Professionally, personally, and economically, whatever you want it to do. You have to have a vivid picture in your mind. What's that going to look like, right? And then two, you have to have passion for that. You cannot do something because your parents want you to be. I'm sorry, you can't. You cannot do it because of economic reason. I wanted to be a billionaire. No, you have to have passion, something that you really love, something you believe in, right? And of course, you have to have a plan. You cannot just sit in a pillow and sleep and say, oh yeah, I'm gonna get there. No, you're gonna have to have a plan. You have to have a plan A, plan B, and plan C, all the way to Z. Because the plan A is not gonna work, plan B is not gonna work. You have to improvise and be able to change and adapt. And last thing is perseverance. You're going to get in the horse, you're going to fall down many, many, many times. So you have to have perseverance, and you have to have support system that will make you go. The other thing is the relationship. Relationship means collaboration, building bridges. You have a great opportunity here to know somebody, meet somebody, collaborate in something, even something small. If I get a phone number and email, you never know. I've been taking a lot of phones, a lot of emails here. So it's very important to build a relationship. Good relationship, positive relationship, okay? And then takes time to build anything. I have young adults like you are. You don't go to the last step, the 9th floor before you go to the 0th floor. Give yourself some time to grow and develop and learn. And then everything goes with collaboration and teamwork. But one thing I don't put in my equations, so it's copyright, I should put a star in there, is in the end of the day, wherever we work at NASA, work in industry, work in academia, work in anywhere, yeah, in the end of the day, we all are human. You have to have empathy to people that less fortunate than you are and be able to give back to community. That's my success equation, and it encompasses planning, thinking, perseverance, connections, collaborations, and hard work. It doesn't come easy. Somebody asked how many hours do you sleep a day? I'm lucky if I sleep 5 hours a day. My husband said I'm gonna die young, but I haven't died yet. So, but what I'm saying is you have to be balanced everything. I have a family, I'm a mother, I'm a volunteer. You cannot just throw yourself in a career and say that's it. No. Allah subhanahu wa ta'ala made you live as a human being, complete balance. So you have to think about that. This is just professional success. And you can tell this, if you want to renovate your kitchen, you can do this, use the same equation too. Just to let you know. That's all what I have regarding collaborations and success.
Yes. So in addition to that, Dr. Tahani, this is really great. I can't really give advice because I don't feel that I'm in the level where I can teach people about success. But the one thing that I would say for young people who just arrived and they're studying and they're seeing their future is your ability to take risks. And many people, especially young people and women especially, they're looking for things who have low risks. They want a guarantee. People think I will go in this discipline because I'm guaranteed job, I'm guaranteed to this. Well, the one thing I learned in my life, I traveled many places. I have 3 citizenship. My true ones, I don't have any identity for. I don't have an Egyptian ID or a passport from Egypt. I don't even have a birth certificate. My official ID, I'm a US citizen who's born in France. The truth is, I'm Egyptian citizen who's born in Libya in the wartime, so I never have a certificate. But the one thing that is very important is that in life, there is no guarantee. If you look for guarantee, you are losing your time. Go there and fight and apply this equation, the passion, the planning, and the perseverance. So that's one thing. And the second thing also is that success is not how fast you reach your objective. That is an Egyptian myth and an Arab myth in the media. They show you, look, this 26 years old, he's an astronaut. This 18 years old, he's a professor in Harvard. And all of these things you see in the news. Success is your ability to fight for your dreams all the time, whether you reach it or not. And it's not how fast you reach it. So learn to be a fighter and perseverance as in this equation, because that is what makes you strong.
Yes, 100% agreed. Could have never said it any better. So in terms of if we apply the success equation and work hard, and in terms of looking at policy recommendations, so in the future and what we can do, the lens of policy recommendation and a call to action is very necessary. So what can you say to how can we emphasize the importance of advocacy and public engagement in raising awareness about the role of space in addressing environmental challenges?
So from my perspective is, like I said, NASA, we provide science, information, technology to be able to do that. One thing I always advise is be able to educate yourself about the topic, be aware what's happening around you, and what can you do in your level. Everybody can do something in their level, right? You said, oh, I'm not there, I haven't finished my undergraduate. Yes, you do. You can contribute back to community and society and be able to help other people. Like I mentor graduate students that you go and teach in elementary school about weather and climate change, about things like that. Everybody can do something. But what I'm saying is you have to find what you're really passionate about, be able to give, because you have to give it not with your hand, not with your brain, it's with your soul and your heart. And people see that. So what I'm saying is I am not the policy maker. I'm an enabler to provide you the right information, the right technology, right data to be able to allow to the policy maker, to the government to be able to make a change. That's all.
Yes. So again, as we said, that we think that space is extra money spent and it has no future. I mean, for us, we think that when you graduate working in space, maybe the opportunities are limited, which is not true. I can give you my example. I have a master and a PhD in astronomy and astrophysics. However, I was recruited as an associate professor in internal Earth geophysics to look for earthquake. And then I was hired as a professor of electrical engineering and computer science. And then I was a professor of geology, then of astronomy. And so you can go from back and top to the Earth simply because the space is very diversified field. So if you are fascinated about space, go for it. You don't need to have a specific degree. There is no degree that is the closer to space than others. It's your fascination with the science that make you closer to the opportunities.
Yeah, and there is a lot. Excuse me. There is a lot of internship for NASA for actually high school or undergraduate, graduate, postdocs, and available. That's for students. And there is, of course, we have a lot of industry that we work with, right, across the board, nationally, internationally, and academia too. So there is a lot of doors that you can knock, and if you're interested in a field, you can be able to do that.
So, in closing, let's reflect on the urgent need for collective action in leveraging space applications for environmental sustainability in the Middle East and beyond. We can accelerate progress towards a sustainable future by pooling resources and fostering innovation. Let's embrace this challenge together, working across disciplines to develop and deploy solutions for a better tomorrow. And let's give it up for our speakers. So now we would love to hear from our audience, both in person and in the live stream. So if anybody would like to ask a question, please go ahead. Yes, in the front row.
Hi everyone. Thank you for a great speech. I loved your thoughts about climate change and all of that. So I'm personally not a scientist. I'm in finance, actually in medtech. So my question for you today, we know with all net zero initiatives, for example, ESG reporting and that kind of thing, how can business professionals or entrepreneurs support you in your mission? And also, how can we reduce those environmental costs, right? For example, if you look at AI, all the costs that are related to training the model or just tweaking all of that, there's a lot of things that affect our environment. So we'd love to have your professional opinion regarding that and how can we, as business professionals, help you with that. Thank you.
Okay, so in our field is all connected, right? So I'm a project manager, so project management is not only the technical side, right? We just show you the result of that. There is a lot of work goes behind background. You have technical aspect of it, you have cost, budget, economics, and you have schedule. You have to line up this triangle, right? Be able to make any missions. Sometimes we are really good at technical. We're not so good at programmatic and cost and schedule. So we need all kind of skills to be able to do that. We have, as much as we have scientists, engineer, we have economics, we have budget, we have procurement, we have arts, we have all kind of activity. And there is a lot of company that helps us do that. Like I was telling somebody in lunchtime is we don't only come with our requirements by ourselves. We develop by National Academy, develop the requirements for the next 20, 30, 50 years. And then we take those ideas and we develop architectures and we test those architecture. Like one of them, the Roaa showed that has the Earth System Observatory. We had 174 architecture. We have to down select from those to 4. And our bosses have to select based on what? Based on cost, schedule, international partner, with the Japanese, with the Indian, with the European, everybody that's involved in it. So it is the core based on our budget, current budget and economics plays a big role in that. And we are really trying to ensure that we confirm with our stakeholders that we can be able to do that. Like I have a mission right now is like $3.5 billion, right? So we need to be within cost, so be able to do the next missions that's gonna follow that. So economics is very important, and there is a lot of conduit to be able to come and help us, to be a reviewer, to be able to be part of our team, and so on and so forth. Thank you for the question.
Do you have any other questions? Sure, second row in the pink, in the far right.
Thank you so much for your talk. That was really inspiring. So I know you're not policymakers, but there's a longing absence of the Arab world from the commercial space scene. So number one, my question is, what do you think is the most pressing challenge that the Arab world face in engaging in international space efforts? And two, how can regional entities like local space agencies and space leaders abroad like yourselves help facilitate such collaborations in on an international level?
Thank you for the question. I guess the question to me. So NASA, we partner with anybody that brings something to the table. And I'm very pleased to let you know that UAE has a great space agency. Saudi Arabia has a great space agency. We have some astronauts already in ISS. Egypt has a space agency. So now they are in the beginning, right? So we're trying to help them. And NASA has the Artemis Accord. We have almost, I believe, maybe 14 or 15 nations that signed that. How we be able to play in space together, who has what and do what together to ensure space is safe for everybody. So we are involved in all aspects of that. But I always say the future to the young people. The future, they are the one who really can change the world. They are the one who can set policy and be able to be involved. Like now we are, Sam and I and a lot of other colleagues go and talk internationally. Like I was in Azerbaijan giving talk there, right? It talks about how we can be involved together. I have a project in Kenya. How can we involve female understanding the water and Victoria Lakes? Now we are going to, like I was telling another young lady here, we're going to South Africa, talk about astronomic and things like that. So we are involved everywhere, but everybody have to come something in the table. And I really, really think the future is about educating yourself and be able to get involved and reading and how can you be involved and figure this out yourself. Nobody gonna come and tell you, we want you. You have to come to the table, right? That's the way it is.
So a quick follow-up for the Artemis Accords, I know UAE and Saudi Arabia are already part of the Accords just a few years back.
Right.
But for I know also we have space agencies in UAE and Egypt. I
Sure.
actually worked for the space agency in Egypt
Right.
for 8 months. But there's some space activities that we're not allowed to do for maybe if we think about launch providing space activity or launch providing segment, or some for satellite imaging, for example, there's a lot of restrictions on things that we can do and we cannot do. So there is a bigger umbrella that we're under for international space law that we cannot go beyond for such activities, and this is why we stay limited for certain activities that we can do or we did then back in 2021. So we're only doing satellite programs, but we're not fostering other programs in the space agency. So that's one part, and the other part also for NASA partnerships, there's restrictions on an individual basis as well. There's ITAR restrictions for internationals to work for NASA. So these are the part of the question that I had on policy, on how to make a better policy framework so that this space is actually for everyone and not just a piece of paper that says, okay, this is the Artemis Accords, we have UAE and Saudi Arabia, but we're not actually acting upon it.
Okay, so if I may, I'm not a policy person. Like I said, and NASA does not make policy, but I know we have a team at NASA that's they call the Office of Intergovernmental International Office. They do all our agreement with any international activity. And then it have to go through the State Department, and the State Department have to verify and validate all of this. But what I'm saying from a personal level, and how can we be involved? We, if let's say if UAE or Saudi Arabia or Egypt want to come and maybe build their own satellite, they have to be able to sustain that, be able to understand what they need to do and why, right? You cannot just come up with a problem, with a solution too, to be able to partner and give you some of our technology to be able to do that. That is from my perspective. I don't know the detail because I'm in the technical side, but if you have a specific incident or specific questions, I may take it back to my team and they probably can have a formal answer for you. So I'm sorry that I don't know all of this, but we are very encouraging everybody to sign the Artemis Accord. And actually, I'm not sure if Egypt signed it, but I know other countries did. So, Essam, you have any experience with that?
Yes, I would like to say one thing about the space program in the Arab world, and how they're starting and how they are evolving and where they go and what the challenges that they meet, that they are into, having worked with many of the local space agencies in the Arab world. There is different schools, and the best one on the school is one that you don't know. So I say the best space agency in the Arab world is one very few of us would know, is in Morocco. Morocco started its space program based on science questions. They know what they want to do with their space program. They want to do water management, risk management. They have the climate change issue, and they built their space program around these very well-defined scientific questions. It was never about the prestige, about famous, about dressed with logos and the patches or being astronaut, none of that. They started from the base and start to go up. And then we have Egyptian Space Agency, which started with NARS, with remote sensing, started very similar to the Moroccan one. It started, it's based on resources, and then it started to go to manufacturing the satellite. But then we have another problem, that the conception that space is prestigious. It's not about utility, it's prestige. And the problem of space for prestige, that now you are competing with many things for prestige. With football, TikTok, and anything. So people start to lose interest. Well, why would I spend 100 million for prestige? Look, yeah, this YouTuber just came to the mall, and now I'm on the face of all of the magazines. It's a challenge for space. We've seen it. I don't want to mention anybody by name, but we've seen that. Many programs stopped because other programs attracted the attention. But I think where the Arab program should be, our space program should be on climate change, because it's nobody's job to understand our climate and our risk than the other. We can't go and say to the CNES in France or ESA or NASA, please study the problems we do have. That is our job. That is our mission. We should provide these observations and collaborate with NASA based on this. So we're bringing these observations to help. So what happened in the Middle East can help understand what happened, the desertification in the southwest of the United States. You can exchange the data. So if you want to be an active member of the space community, you need to be providing data, not just the will to launch and manufacturers.
But then Essam too, if I may add to the question, I'm sorry, is our data is all open, right? Open. So how to use the data is a totally different story. How to do, so we have a lot of satellites that look at all the Arab worlds, right? So somebody from the scientist perspective, from the universities, from the organization, look at those data and try to really understand what does this mean to them, right? And NASA provides to everybody for free. We launch it, we paid for it, you got it. Somebody needs to analyze, and that's depend on an institution and a scientist in those countries. So, if I may add.
All right, we have, I think, time for one more question. On the right-hand side, yeah, behind you.
And then even if the session finished, we'll be outside, Essam and I, if you want to stop by and talk to us, we'll be more than glad to answer any questions.
thank you for your panel. My name is Crystal. I work at Bechtel, helping out with the Artemis II. I've been fortunate to be able to attend a lot of NASA conferences. 2 months ago, I chased Bill Nelson down the hallway asking him for a job. Yes, here I am. But one of the things that they talked about at many of these conferences that you mentioned as well is the point of gathering all this data, making sure that you're not on policy or lobbying, you actually gather data.
Right.
However, especially with climate change occurring so quickly, how is it, and it takes time to be able to pitch these ideas, to be able to acquire the funding, to construct these projects, send them out before you actually gather the data and people are able to use it. So my question for you is, do you feel like you guys are able to act in a timely manner to keep up with climate change when it comes to gathering this data when it's changing so quickly and these projects take a long time to come about? And if not, what do you think can be done, whether it be on the policy side or just acquiring the funding, getting more people involved in the project? What do you think that would be?
That's an excellent question. So actually, NASA have been very active in that area, and they created an Earth Science division. They call it Earth Actions. What does it really mean, right? So you get the data, you analyze it, you understand the risk from our model and our satellite. What does it need to be done for disaster area, like for fire, for flood, for things like that? And they're working very, very close to a lot of organizations to be able to do that. So I will ask you if you be kind enough and search NASA Earth Actions. You'll see a lot of activity in that regarding that. And if you want to talk about it a little bit more later, I'll be more than glad to do that. Thank you.
Okay, well, this is the conclusion of our session. Thank you guys so much for coming again.
Thank you.
And thank you, Dr. Tahani and Dr. Essam. We're very honored to have had you here today. Thank you, everybody.
Thank you.